All right, so here we are looking at 7.2. We're going to start out with number 39. So here we just want to simplify the expression. So when I'm looking at this expression here, I have another guest joining us for class. Welcome, Maddie. Maddie, do you have any questions for the 7.2 homework? All right, we're going to assume not, but if you do, let me know. So here we got 7.2, number 39, and we're looking at just trying to simplify this expression. So I have a root 3 on top, and I have a root 3 on bottom. So if I wanted to rewrite this thing, I could write it in exponential form. More often than not, I will rewrite it in exponential form just because I think people have a little bit easier time seeing this thing. But really, it's the same either way. So I'm going to just represent it as 4 to the 1/3, whoops, over, here I have 32 to the 1/3. So if I have something that looks like a to the x divided by b to the x, this can be simplified to just being a over b raised to the x. So here again, our our property of exponents coming into play here. So I'm going to rewrite this thing as 4 over 32, all raised to the 1/3. And again, if you want to have a cube root instead, you want to have it represented like this. It means the exact same thing. Doesn't matter either way. So what am I going to do next? I have 4 over 32, so I'm going to simplify this thing. I'm going to say, okay, 32 divided by 2 is 16, divided by 2 is 4. Cool. So this thing is going to turn into 1/8 raised to the 1/3. And this one down here, we'll do consistent notation here. Cube root of 1/8. So now I want to either do one of two things. One, I want to maybe change the way this 8 looks, or I just want to split this thing up and look at each individual cube root. So I'm going to split this up back into each individual cube root. So as I do this, I'm going to split this out. Let's get Holden in here. And so I'm going to say, okay, well, this thing is going to equal 1 to the 1/3, which is pretty straightforward. And this could be your final answer as well. But here we're going to continue simplifying. So it depends on what this bottom term is. So like say, for example, this was, I don't know, 7, right? If it was 1/7 raised to the 1/3, this could be your final answer. But here we can simplify a little bit further. So let's split this into 8 to the 1/3 on the bottom. Whoops. And we have 1 to the 1/3 on top. 1 to the 1/3, which is the cube root of 1, which is just 1. Here I have 8 to the 1/3, so the cube root of 8 is just 2. So my final answer here would be 1/2. And you can do that from here as well. One thing we could do is we could rewrite this as 8 to the -1. And here, this is a cube root. I can move this -1 onto the outside. So if I wanted to rewrite this as cube root of 8, and then this whole thing raised to the -1, we can rewrite it like that. The cube root of 8 is 2. 2 to the -1 is 1/2. So it doesn't matter which way you pursue it, which notation you use, we're still going to get to the same conclusion. Any questions on 39? Perfect. Looking at 47 here, we just want to write the expression in simplest form. So basically, I see this thing and I have a 6 root on the bottom with 81. And I want to find a way of simplifying this. I do not want a radical in my denominator. So I'm going to have to maybe come up with a clever way of getting this thing to go away. So when I look at this, I see 81, and it may not be immediately apparent to you like what 81 is or like what its significance is. But basically, if I have 3 raised to the 4th, it's going to give me 81. So again, I don't really expect you guys to know like what these things are off the top of your head. But one thing we could do is I could say, okay, well, what does 81 break down into? Breaks into 3, which is the hardest number to draw on the stylus thing. And then what does 27 break out into? And then continue breaking this down till we get to our prime factorization tree. Okay, we can always do this. So again, don't stress needing to memorize 81. You will see 81 pop up a lot, 21 pops up, 27 pops up a lot. Like, we'll see these cubes. Again, if you want to identify like one or two numbers raised to the fourth, that'd be helpful. But again, don't feel like you need to do it. So I'm just going to rewrite this thing using 3 to the fourth. So now I'm going to just rewrite this as 2 over the 6th root of 3 to the fourth. Okay, this thing has a fourth degree. This thing has a index of 6. So this radical here has a force field strength of 6. To break out, this thing needs a force field strength of 6 as well. So how am I going to make this a 6? I'm going to need to multiply by the 6th root of 3 squared. So if I do that on the bottom, I need to also do that on the top. So here I'm going to multiply by the 6th root of 3 squared. The goal here, again, is to get this degree to match this index. This is what's going to get me there. So again, if I want to get to 6, I do 4 plus 2, right? 3 to the fourth times 3 to the second equals 3 to the, oh my goodness. This is, whatever, you can see it fine. So this is going to give me 3 to the 6. So when I'm doing this, it's going to simplify to look like the 6th root of 3 to the 6. And now on top here, I just have 2 on the outside, and then here I have the 6th root of 9. So there's nothing really I can do with this 3 squared. It's not strong enough to break out. On the bottom, I'm going to simplify to just call this thing 3. Because again, I have 3 to the 6. 6th root of 3 to the 6 is just 3. So on top here, then I get 2 root 6 of 9. And I am done. Please do not cancel this 3 here with this 9 here, right? This is a root 6 of 9. This is just a 3 on its own. So these things do not cancel off. Any questions on 27? Or 47, excuse me. Perfect. Let's look at 71 here. So here we just want to write this thing in simplest form, assume all the variables are positive. So basically just don't worry about the variables giving you any trouble. So as I look at this thing, I have a square root times a square root. If I have a square root times a square root, I'm going to multiply the things underneath. So I'm going to do that as my first step. So I'm going to call this thing 2 because I have a constant right here. I'll actually do each of these as its own color. So I don't have any constant that I see here, so it's assumed to be 1. 1 times 2 is 2. For my x, I have an x here, and then I have no x's over here, so I just have x to the first. For my y's, I have a y here, I have y to the third here, so I have y to the fourth. And then for my z's, I have a z over here, and a z right here, so I'm going to get z to the fourth here, so I'm going to get z to the fifth. Okay, as I look at this thing, I don't see a number for my index, so that means this thing right here is 2, right? This is just a normal square root. So if I've got the square root of all this stuff, that means I'm going to split these things into nice squares if I can, right? Because that's going to be what comes out of this thing. The 2 is going to remain a 2. There's no square there, nothing I can do. X is going to remain x, nothing I can do there. The y to the fourth, I'm going to split into y squared and y squared. The reason I'm doing this is I can take this y squared out. So it's going to come out as just a y. The z, I'm going to split into z squared, oops, I'm using the wrong. We're using purple instead of indigo here. Get with it. Z squared, and z. So when I look at this thing, I'm going to say, okay, well, what is coming on the outside? I've got a y squared, a z squared, and a z squared. So on the outside, this is going to become y, z, z, and all these things are being multiplied. So just keep that in mind. 31 and 55, yeah, we'll get to those too. Get my square root here. So now looking at what's left underneath, I have my 2, I have my x, and I've got one of my z's left over. So now in terms of my final answer, what's my final answer going to be? Y times y gives me y squared. Z times z gives me z squared, square root xz. And I am good to go. Any questions here?
Wait, what about the z squared and the y squared that are left, like, in the problem?
The final answer here, you mean?
No, like, if you were to take out only one of the square things, wouldn't there still be, like, a y to the second power and a z to the second power in the problem?
I have my y to the second power and z to the second power right here.
Yeah, but there is another one originally in the problem, so wouldn't that still be in the, like, the square root thing?
Nope, so this y squared on the inside turns into a y on the outside. So when
Oh,
I take
okay.
the square root of a square, I just get the thing itself.
Oh, I get it. Okay.
Good question. What else we
Shoot,
got here?
Mr. G.
Yeah.
I was just wondering because on the classroom, so 7.1 homework was due on Friday, and then 7.2 is due today, and then it says 7.3 is due on Wednesday. So I was just wondering if there's any homework due tomorrow.
There is not.
Okay, so we just have a break.
Yeah, I mean, basically it's a catch-up day.
Okay.
Does that make sense?
Yes.
Cool.
Thank you.
Any other questions on 71 here? Perfect. All right. Scoot down a bit here. Check out 91. So again, I wouldn't worry about this one too much, but we will talk about it. So here's like more just pulling in our geometry knowledge. So we have the area of two circles are 15 square centimeters and 20 square centimeters. So I'm going to say circle 1, I guess I'll say the area of circle 1 equals 15. And I will say the area of circle 2 equals 20. Find the exact ratio of the radius of the smaller circle to the radius of the larger circle. Well, in order to do this, I need to know that the area of a circle equals pi r squared. So once I know that, I'm able to solve for my radius. So I look at the first one, I'm going to say, okay, well, this is going to be 15 equals pi r squared. So when I'm solving for this, I'm going to divide by pi first. So I get 15, over pi equals my r squared value. And I'm going to take the square root. I'm going to take the square root. Keep in mind that when I'm taking the square root here, it's plus or minus, but since I have a circle, I have the limitation that I can only have a positive length for my radius. So my radius here is just going to be the positive one. So it's going to be the square root of 15 over pi. So that's the radius for the first one. For the next one here, I'm going to do the same steps all the way through. The only thing different is now I'm doing 20. So my radius for this one is going to be the square root of 20 over pi. And now it wants us, so the actual goal of this problem is to find the exact ratio of the radius of the smaller circle to the radius of the larger circle. So I'm basically going to do the red one over the orange one. So I'm going to just be doing r divided by r here. So when I'm looking at this problem, I'm going to write these things in. Square root 15, actually I'll do it in the same color still, just to stay consistent with it. So here I got root 15, over pi. Let's separate our colors here. Cool. So the first thing I would say I would look at this and do is I see this is a square root, and so I'm going to split my root into my numerator, denominator, and I'm going to see that I get my root pi's to cancel off. So here we got root 15 over square root pi divided by, that's why I use this double sign here, root 20 over root pi again. So if you want to just cancel off these root pi's, you can. If you want to do the whole flip multiplication thing, you can. So if you want to think about this as being root 15 over root pi times, and then flip this root pi over root 20, you can. So this becomes root 15 over root 20. Again, I have a root here. So if I got a root on top, root on bottom, I have the same degree. We can now combine these things under one root, which is 15 over root 20, or excuse me, root 15 over 20. So now from here, I'm going to simplify. So I can divide this entire thing by my 5s. So I get root 3 over 4. As I look at this thing, I'm going to split this out again. So I get root 3 over root 4, and then root 4 simplifies to just be 2. So my final answer here would be root 3 over 2. Any questions on 91? Sorry, the work kind of like took a swing around this way rather than just continuing down. Perfect. There were 2 other questions asked. That's 31 and 55. So let's get those ones. All right, let's see. We got 31. And here we got 55. So let's start with 31 here. So we're looking at 31 here. I just want to simplify the expression. The biggest thing I would try and advise you guys to get in the habit of doing is starting to break down these numbers. When you see a 125, I don't want to personally think of it as a 125. I want to think about it as 5 to the third. But before we get into doing that, let's just do the multiplication part on top. So here I have 125 raised to a power times 125 raised to a power. If I have 125 and 125 being multiplied, I'm just going to add their exponents. So this is going to be 125. Here I'm going to get 2/9 plus 1/9, which is 3/9. 3/9 is 1/3. So there's my first move there. And now I want to look at this thing and say, okay, well, what is 125 raised to the 1/3? The cube root of 125 is 5. Here I get 5 to the 1/4 on the bottom still. These 4s are coming out less than ideal. So now if I have 5 to the first, right, this is to the first even though I don't see it, divided by 5 to the 1/4, I'm doing division. My division property of exponents says I'm going to take and subtract my exponents. So now my final answer here would be 5 to the 3/4. Any questions on 31? Perfect. Looking at 55 here next. Just want to perform the indicated operation. So here we're just adding these things up. Right now, as I look at this just at like a first glance, I literally can't do this, right? I have 176 and I have 11. So if I wanted to add these two things together, they need to have the same root radical sign and the thing inside of it. So here it's got root 4 and root 4, which I like, but then it's got 176 and 11. I'm pretty stuck there. So I look at this and I say, okay, well, maybe there actually is a way that I can add these together. Maybe this one can be simplified, because I look at the root 11, there's nothing that breaks down further from here. So 11 is just 11 times 1, it's a prime. So there's nothing I can do to simplify that. There's no way this is changing at all. This 176, though, looks like to me it breaks down. If you're not sure what to do, I would say always just look at it and say like, oh, 176 is even, then you can go that route. Or you can say, oh, I kind of want it to be 11, so maybe I'll try dividing by 11 again. Multiple approaches, just really trying to break down this 176 to a prime factorization tree. I'm going to go the route of just saying, okay, I see it's an even number, so I'm going to divide it by 2. So 176 divided by 2 gives me 88. And then my 88, and that can be 2 and 44. Looks like it can be 2 and 22. And this looks like it can be 2 and 11. And now I see I have my prime factorization here. So I'm just going to rewrite this one as 2 on the outside, fourth root of 2, and I'm going to write this to the fourth. The reason I'm writing it to the fourth is I want fourth things, right? 1, 2, 3, 4. I've got 4 of them. So I'm going to rewrite this as 2 to the fourth times 11. Now again, what can happen if I have a fourth degree thing inside of a fourth root? I can bring it on the outside. So this 2 is going to come on the outside now. So I'm going to have 2 from before times, and now I've got this 2 right here, and then I've still got my fourth root of 11. So now I look at this and I say, oh, I can actually add these things together. So this is just going to give me 4 fourth root 11, and I'm going to say plus my 5 fourth root 11. Again, this matches this, so I'm saying 5 apples, there's going to be 4 apples plus 5 apples. Cool. Ends up giving me 9 apples. It just happens that my apples here are fourth root of 11s. Not quite as tasty as a Mac. Any questions on this one? Perfect. Any other 7.2 questions before I close out this homework session? Just in terms of the recording. Alrighty, we're good to go.